Good afternoon, students.
Namaste, ma'am.
Yeah, good to hear that. So I say that in Hindi we say खुश रहो, अच्छे से पढ़ो, or we say it in English. God bless you. Keep studying and keep working hard. So should we start or we still have students to settle in?
Ma'am, 5 minutes to settle down.
Okay, I'll wait then. Till the other students come, I'll ask the students in the class. If you have not completed your homework, I gave you certain numbers 37, 59, 24, and 29 to write the electronic configuration. Just be
Yes,
ready with
ma'am.
your answers. Just be ready with your answers.
Okay, ma'am.
Okay. Yeah, please allow me the screen sharing. So I believe all of you are ready to start the class.
Yes, ma'am.
Okay. So what is the reply to the homework? 37, 59, 24, 29. In that order, what is the electronic configuration of 37? Atomic number 37 or number of electrons 37. What you would be writing?
1s2, ma'am.
Yeah,
2s2,
yeah,
2p6,
okay,
3s2,
yeah,
3p6,
right,
4s2,
yeah,
3d10,
yeah,
4p6,
right,
5s1, ma'am.
correct. See, I have shown you the other way. What you said, student was correct. But here I wanted to understand you one other way of writing the configuration of the elements. As you can see on my screen, I have written it as in terms of atomic orbitals as filled by Bohr-Bary's law 2818, 288, 1, right? And then I have written Kr. Can somebody tell me what is the name of the element having symbol as Kr?
Krypton, ma'am.
Okay, correct. Krypton. See, here you can see there is another way of writing the configuration of element, right? Sometimes, just in order to save our times, what we do is we take the clue or the configuration from the zero group elements and then write them all, right? Now, as you can see, Krypton on the right hand side of my screen, you can see that Krypton is assigned atomic number 36. I believe you can understand it and you can, it should be clear to you. It is a concept of, let's say, class 9th, right? We have done helium atomic number 2, neon atomic number 10, argon 18, krypton 36, xenon 54, radon 86, sorry, right? So when I am writing KR, that means after the configuration of krypton, we have to write S1. So it will be, instead of S1, it should be written as 5S1, right? Is it clear now that this is another way of writing the configuration of elements? So you must remember it also. The atomic numbers of the zero group elements must be clear to all of you, or rather you should remember them. Helium, neon, argon, krypton, xenon, and radon. Is it clear?
Yes, ma'am.
Okay. So, atomic number 59, that I have just displayed the configuration for you just in order to save certain time, because I'm pretty sure that you are clear with above, and with the help of above principle, you can write the configuration. Now coming to the atomic number 24 and 29. Can somebody tell me for 24? Yeah, please speak.
1S, 2,
Yeah.
2S2, 2P6, 3S2, 3P6, 4S2, 3D4.
3p6. Then you said 4s2 and
3D4.
3d4. Is there anyone in the class who does not agree with this configuration? Similarly, for 29, you must have written 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, right? But both the configurations are incorrect. This is also incorrect and this is also incorrect. Please remember, 24 is the atomic number of chromium and 29 is atomic number of copper, right? And we say that whenever you have a choice to make between 3d4 and 3d5, it has to be 3d5. The correct configuration of element with atomic number 24 is, the last one will be becoming 4s1, 3d5. Similarly, for atomic number 29, it will be in the last, sorry, initially it was 4s2, 3d9. Now it will become 4s1, 3d10, because that's my habit, because that's the correct configuration of copper. Please remember and please note it down in your copies that exactly half-filled and exactly fulfilled orbitals are more stable than nearly half-filled and nearly fulfilled orbitals. Do you want me to write it down? Or you know about it? Please, any one of you can convey me the message.
Yes, ma'am.
You're clear about it?
Yes, ma'am.
So then why we have an incorrect configuration of 24 and 29? If you know the rule, then please apply it. That exactly half-filled and exactly full-filled orbitals are more stable than nearly half-filled and nearly full-filled orbitals.
Ma'am,
Now, yeah, please speak.
can you explain that 59, ma'am?
Yeah, 59, I'll explain. 59 is a F block element. I was coming to that, right? See, this is the modern periodic table. I'm not too sure whether you have been taught about the periodic table or not in your schools. Can somebody apprise me on that whether you have been taught about it or not?
Yes, ma'am.
You are taught. Okay. Now, you must be knowing which is S block, which is P block, D block, and F block. If you look
Yes,
at this
ma'am.
periodic, okay, thank you. If you look at the periodic table carefully, please remember, if copper is an exception, if the configuration of copper is 3D10 4S1, then for silver, can you predict the configuration without writing? I will say yes. It will be 4D10 5S1 because in periodic table, we are moving to the next period. Similarly, for AU, that is gold, it will be 5D10 6S1. So, if you are clear about the exception of copper, be ready to have a question or the writing the configuration of copper as well as silver or gold, right? Similarly, talking about the chromium, as you can see, what are the elements after chromium? Chromium is followed by molybdenum, which is followed by tungsten, and then Sg is seaborgium, right? So we must be ready with the configuration for 24 and 42 at least. What do we write for chromium? We wrote it as 3D5 4S1. Similarly, for molybdenum, the valence shell will become 4D5 5S1. One interesting fact about this element, having atomic number 106, seaborgium. This is the only element which is named after the scientist Seaborg when he was alive. In the periodic table, you will see many elements like you have mendelevium at atomic number 101, right? But this was named after Mendeleev. But after the death of Mendeleev, right? When he was alive, he was not given this honor of being an element being named after his name. But Seaborgium or Seaborg is the only scientist. When he was alive, this element was named after that. Coming to your query of atomic number 59. Now, F block configurations are usually not asked during the exams. One of the reason is that they have so many close atomic orbitals, D, F, and S, and P. The energies are very less. You cannot be following the orders always. The only thing for atomic number 59 can be said that it is a P block element, right? So I understand that you must be thinking, how can I have 4F3? Right? If you follow the table, you will get this. It looks like 4F2, but it is 4F3, right?
Ma'am, one down.
Yeah.
Ma'am, for carbon atomic number is 6, no, ma'am.
I'll appreciate if only one of you speak. I'm not, you are audible, but not clear to me.
Ma'am, for carbon atomic number is 6, no, ma'am.
Yeah.
We can write it as 1s2, 2s1, and 2p3, no, ma'am. In that way, it is
So we can,
stable and more stable.
no, we cannot. Yeah, that's a good question. I understood your query. Now for that, we need to go back to the chapter of atomic structure. And we must understand few basic things about the energies of the orbitals. If I can translate your query, you are saying carbon is having atomic number 6. It is 1s2. We write it as 1s2, and then we write 2s2, and we write 2p2, right? Your query is that you wanted to write it as 2s1 and 2p3. Exactly half-filled S and exactly half-filled P. Have I interpreted your query correctly? Please.
Yes, ma'am.
Okay. Now, this type of exchange can occur only between D block elements and later on in the F blocks. The reason being, the shape of S orbital, I believe you have done it in your school. S is a spherical, P is having 3 dumbbells, right? Like this. For F, we draw 5 dumbbells. And for F, it is still difficult to draw that, to have 7 dumbbells, right? So we say they have a pretty larger surface area. More importantly, if you recall the general electronic configuration of S, P, and D block elements, for S block, we say this is NS1 or 2. For P block, this is NS2, NP126. When we move to D block, what we say? It is F-1, D1 to D10, NS1 or 2. More importantly, if you look at the configuration of any of the D block elements, let's say take it for 22. 1s2, 2s2, 2p6, then 3s2, 3p6, 4s2, 3d2. Do you realize where is this d electron entering? Is it entering into the valence shell electron, valence shell, or is it entering into a penultimate shell? Penultimate shell, right? So it is, therefore, the complexity of interactive forces between electron and proton are very, very difficult to understand and interpret. Whereas in case of S and P block, the last or the deciding electron is entering into the valence shell. In this case, it is entering into N-1 shell or the penultimate shell. If I talk about F, it will be entering into anti-penultimate, right? So the electron, let's draw a D block atom. Assuming it to be the valence shell, which is having 2 electrons, the last electron is entering here, which is much more closer to the nucleus. More importantly, if we draw the atom, as we say, the orbits are elliptical in shape. If I draw the elliptical orbital, what will happen? After 2 or 3 orbits, this is assumingly 3s, 3p, and somewhere here we will have 3d. Here we will have 2s, 2p, and we don't have a 2d. This is the nucleus and this is the 1s orbital. Can you see the distance between 3s is here and 2p is here and 3d is here, right? The distances become 3s I have drawn a bit large. Let me correct it first. See, the 2s will be only this much, right? Or 3s will be only this much distance. As a result, as you can see, electron is at a more distance in 3D. What about the 4s? if I can draw another orbit into it, probably I will not be able to make a complete ellipse. So this one will be 4s. Can you see the distance between 4s and 3D being practically same? Will you agree?
Yes, ma'am.
That is the reason this exchange is possible, right? Because we have to get away with the image, circular image, for understanding this concept. The exchange is possible only when two are of equivalent energies, right? I'm saying equivalent, not equal. The energies are comparable. But if you take the example of carbon or silicon below it, you will see S and P. We say S and we consider S and P orbitals as compact. Compact means that in a smaller space, many electrons are there. But if I talk about D and if I talk about F, that means they are having, we say they have a diffused structure. Assume that you have a plate on which you have, say, 50 grams of sugar is spread over it, right? In the second instance, you have, say, 50 grams of sugar kept in a bowl. You will agree that it is easy to transfer the 50 grams of sugar from a bowl rather than a plate. Similarly, since D and F orbitals are having a diffuse structure, that is, electrons are spread over a larger area. Therefore, that is the second reason why such exchange are not possible between S and P orbitals. Is your query answered, students?
Yes, ma'am.
Okay. More importantly, I'll give you an advice to make it clear that I have deliberately put this slide taking a periodic table from the other chapter to make you understand that for 24, 42, 74 and 106, you have to do an exception. Similarly, for 29, 47, 79 and 111 has to be exception. Please do not divert from the concept. Just keep it in mind that you have to do or you have to apply this to only these elements, right? I have explained because I believe that queries has to be answered. Therefore, I answered your query, right? And that was, I appreciate that was a good question and it will help us in understanding lanthanide contraction in class 12, where we will understand that size of lanthanum hafnium LaNHF is practically same, or yttrium and lanthanum 39 and 57. Below scandium, you can see them, right? So we'll take it up in when we talk about DNF elements. So this is clear to all of you. Okay. Now, can somebody explain Hund's rule to me? I believe since you have done in your class, are you sure what is Hund's rule? Can somebody explain it to me? Any one of you can speak so that I can hear that discussion won't be. Please pick up a mic and speak.
Ma'am, in an atom, pairing of electron doesn't take place until the orbitals in the same structure get one electron each, that is singly occupied.
Okay, agreed to an extent, but I will tell you one interesting thing about it. I will show you the options. What you said to me has to be corrected, or I will say elevated for a clear understanding. If we take the example of nitrogen, atomic number being 7, configuration will be 1s2, 2s2, 2p3. We'll focus on, 2p3. We will focus on only on the 2p orbitals, right? Now I will be drawing and you will be telling me which one is correct and which was incorrect with the reasons, right? So now is the structure number 1 correct or incorrect? This is the first one.
Incorrect.
Correct? Is it correct or incorrect?
Incorrect, ma'am.
Incorrect. Okay. The second one.
Incorrect, ma'am.
Okay. The third one.
Correct, ma'am.
Okay. The fourth one.
Incorrect, ma'am.
This is incorrect, you are saying?
Yes, ma'am.
Okay. The fifth one.
Fifth one is correct, ma'am.
Okay. The sixth one.
Correct, ma'am.
Okay. The seventh one.
Incorrect, ma'am.
Okay. Now, kindly tell me the structure number 3.
Three is also incorrect, ma'am.
Okay. Now redefine, please speak your definition again. What you said was that pairing of electrons starts only when each one of have received 1 electron each, right? Now, why you are saying 4 is incorrect? Each one of them is having 1 electron. You need to tell me the reason why this 4th is incorrect. Why this 7th is incorrect.
Ma'am, electron should be filled in same spin, ma'am.
That was the case thing. That's what I said. You need to improve on your definition. That is most of the time, that is a critical point we miss while doing this activity or while explaining Hund's rule, right? It is very important to say each one of them is singly occupied with the electron of parallel spin. If you don't write this word each of parallel spin, then your answer is incorrect, right? So please pay attention to the definitions if you are asked to write. But for Hund's, I believe we will be given a virtually like a diagram sort of a thing as I gave it to you. But if you are asked to write the definition, make sure that you write each of the parallel spin. Parallel spin means all 3 clockwise or all 3 anti-clockwise. Is this clear to all of you?
Yes, ma'am.
Okay. So now we have N plus L rule. Are you clear about it? Filling of electrons can be done by either above or at times they ask us a question using the...
Ma'am,
Yeah.
we want before slide.
This one? Are you looking for this slide?
The definition one, ma'am.
Huh? The definition one. Okay. Please copy that quickly and let me know. Have you copied it down? Okay, I believe you must have been copied the definition by now. Let's move on and understand what is N plus L rule. Have you heard about it earlier or not? Just let me know if you know about N plus L rule and quantum numbers. So we'll take up them one by one if you are clear about them or not clear, whatever is your reply. Please tell me if you know about these or not.
No, ma'am.
You know that. Okay, fine. Now let's solve this question. Which of the following orbital is nearest to the nucleus?
Ma'am, 3D, ma'am.
Correct. The answer is 3D. It was just to have a quick recap of what you have learned till now. N is equal to 3. So it will be the nearest to the nucleus. Now this one. Which of the following configuration is correct explanation of Aufbau principle?
Fourth one, ma'am.
Okay. Because Aufbau says filling of the new orbital will start only till the time the earlier one is completely filled. Right?
Yes,
Now, as you say that you know about everything about the quantum numbers, tell me about all the values of if I have an orbital in which is represented by n is equal to 4, right? Now, write all the possible values of L, M, and S for it.
Ma'am, for n is equal to 4, L will be 0, 1, 2, and 3.
Okay. M will be
-3, -2, -1, 0, 1, 2, 3.
You said -3, -2, -1, 0, 1, 2, and 3. Okay.
Yes,
Then spin quantum number.
+1/2, -1/2.
See, my question, please pay attention to my question. I have asked for all possible values. All possible values of quantum numbers. Is the answer complete, or do you have any more numbers to be added here?
For every magnetic quantum number, spin quantum number value will
I
be
can
1
hear
by
you, but I can hear you, but I cannot understand you because of the background voices which I am able to hear. So please speak one by one. So please repeat yourself. Yeah.
For every magnetic quantum number, spin quantum will have 1 by 2 and minus 1 by 2.
That's all. Any other addition?
And for every asymptotal quantum number, we have a different magnetic quantum number.
I didn't get you. Can you please repeat yourself?
For every azimuthal quantum number, there will be different magnetic quantum number.
Okay. So what is the magnetic quantum number for L is equal to 0?
0.
Okay. For 1, it will be?
Minus 1, 0, 1.
Okay. For 2, it will be?
Minus 2, minus 1, 0, 1, 2.
Okay. Agreed. So that means all of you are clear that how to find the quantum numbers, right? Now, can anybody tell me, if I ask you to define what is a quantum number, or why do I need it?
So tell the address of electron.
First of all, the keyword which I was looking for, they are arbitrary numbers. I believe you understand the meaning of arbitrary. Arbitrary, or I really do not have any other word for arbitrary, but they are randomly given it, right? Like you must have solved a puzzle, something. If A is equal to 1, B is equal to 2, C is equal to 3, what will be your name in that particular language? You have given these numbers to represent something. When I'm saying 0, it does not mean it is 0. If I talk about L is equal to 0 in this particular case, azimuthal quantum number, what is it doing? It is signifying s orbital. I believe you know that. But what is this 0 signifying here? In magnetic quantum number, what is the significance of this 0? At best, we can say arbitrary can be written as imaginary numbers. They do not have a real meaning. Like half does not mean half. And you can never cancel half plus half minus half, making it as 0. No, you cannot. So please tell me, what is the significance of 0 in this case? Let's simplify it. What does n is equal to 4 tells you? I'm happy that you can write the quantum number values correctly. But every quantum numbers, as someone from the class said, they are the address of an atom. Or sorry, one of an electron inside an atom, right? How do you translate it? If I say n is equal to 4, what type or what part of address does it signify? Like if you have to tell me your address, you will probably tell me your maybe father or mother's name. Then you will tell me the house number. Then you will tell me the street number, street name and number, whatever it is there in the address. And then maybe a landmark, then the name of the city, then the pin code. That's how you classically describe the address of your home or office or school. Similarly, if I'm saying n is equal to 4, What should I look for it? What does it mean to me? How it is different from when I'm saying n is equal to 2?
The electron is in fourth shell.
Fourth shell. Okay, in general terms, what does it tell me?
Can you repeat, ma'am?
In general, if n is equal to 2 means that we are talking about the second shell. That means what is n conveying to me? What is the significance of n?
That is about the shell, the number of shell.
No. Please look at the slide carefully. Look at the word which is written in red. I have purposely put it in red. N will tell this is the historical purpose. Its value can be 1, 2, 3, 4 until infinity. I believe you know that very well. Now, what do I mean? It determines the average size of the orbit or shell or principal energy level and the energy, average energy. Why? See, when you say n is equal to 4, n is equal to 4 means we are talking at a certain distance between the nucleus and electron. N is equal to 4 means the distance between the nucleus and electron will be this much. If I am saying n is equal to 2, that means the distance between, if this is a nucleus, this will be the 1 and 2. We are talking about this distance. Why I am emphasizing on the word average? Because come back to the same sentence that when we say we are drawing them spherical, but they are actually elliptical. Few minutes ago, we discussed that the distance between s, p, d, and f electrons will be different. The orbital will be elliptical in shape. So that is the important takeaway from this slide is that principal quantum number or n decides or it determines or it tells us about the average size and average energy, right? Distance and energy are correlated. Is it clear now that principal quantum number tells us about the average size of the orbit or the average energy of the orbit or shell? Is it clear to everyone now?
Yes, ma'am.
Okay. Now we say that total number of electrons in an orbit is given by 2n square rule. That must be clear to you. There should be no doubt into it, right? Now this is again a takeaway from what we have learned. See, quantum number can have two types of question. One is a sort of a multiple choice question or just like write all the possible value of this, and this. The other can be you are given a reason assertion question, which is a theoretical part of it, which is very clear, but I thought I will be drawing your interest or your attention towards that as the value of n increases, that the number of shell increases, the size and energy, both of them are going to increase. It is an obvious conclusion for the principal quantum number. Moving to the azimuthal quantum number, again, as I tell you, that you must know each and every possible name of any concept, right? The reason being that you must be, if some other name is asked, you must be able to answer the question. So azimuthal quantum number can also be said as angular momentum quantum number or subsidiary quantum number. Most of the times in competitive exam, they ask for subsidiary quantum number or secondary quantum number. If we talk about CBSE or your normal school exams, we talk about angular momentum. Now, can anybody tell me what does L signify? And you have understood that it tells us about the average energy and average distance from nucleus. But similarly, what does L tells us?
L says about the subshell of the atom and it also signifies 3D dimensional shape of orbital.
Very correct. You are right that L, the value, first of all, the value of L is from 0 to n minus 1 and it determines the shape of the orbital. That's the key answer I was looking for. Good. Right? This, since you are able to write that chart clearly, I'm pretty sure that you understand the value of LR from 0 to n minus 1. So let's move on. This is what we have understood. L is equal to 0, S, P, D, F, G, H, that you know. Although our syllabus restricts us to only L is equal to 3, then but we can move always to G and H. They are not a part of a syllabus, but we can know them, right? And I think, I don't remember whether I taught you or some other batches, that L is equal, S, P, D, F are based on a certain words. No reasons given to us by scientists, but S is for sharp, principal, diffuse, and fundamental, right? Do you know this fact or not? Okay. I'm not able to hear from any one of you. Please speak. Do you know about them or you want to copy them?
We'll copy.
Okay. Should I move ahead?
1 minute.
Okay. Okay. Let's move on.
Just a minute, ma'am.
Okay.
I'm finished.
Okay, thank you. So we know about their shapes, so let's move on. Magnetic quantum number, what does it tell us?
It tells about the orientation of orbitals.
Therefore, for P, you have 3 values. For D, you have 5 values. Now, what does it tell us about the splitting of line? In the classroom, in your regular classes of chemistry of a school, you must have done about the Lyman-Balmer Paschen bracket formed series. There you might have seen that the lines are splitting, right? So it explains the Siemens effect. Siemens, there are 2 effects. One is a Zeeman effect, and the other effect which is there in atomic structure is Stark effect. In Zeeman effect, what they do is they take any spectral line. Let's say that is corresponding to n is equal to 2. Now, when you apply magnetic field around it, what happens? That single line splits into S and P orbital. The line of P orbital again splits into 3, indicating P has got 3 direction at which you can find the electron. That is, it has got 3 orbitals, right? Similarly, if you split the line corresponding to D, you will get 5 sublines, right? So it is the magnetic quantum number tells us that orbitals can be in different directions, right? So that is Siemens effect. Similarly, you have Stark effect. In a Stark effect, we apply the electric field. In Zeeman effect, we apply the magnetic field, and in a Stark effect, we apply electrical field. Yeah, electric field. See, it is not to complicate the topic, but it is just to explain whatever happens has to be supported by few things, right? There has to be a factual confirmation. It's not like that we say that I say that it is raining outside. You must peep out to find whether it is raining or not. Similarly, when the scientist explained, the scientist rather observed the splitting of lines, then they understood that every orbit is divided into subshells and subshells have orbitals. Is it clear?
Yes, ma'am.
Okay. This we know because you have understood this concept, you have written the correct values. So there is no reason to spend any more time on it. The spin quantum number, can somebody tell me why we use only plus half and minus half? Why the scientists have not taken any other number?
Ma'am, because they spin only anti-clockwise or clockwise.
So that is represented by plus and minus.
Yes.
Okay. If you remember, when you were drawing cones, so what we did? In each of the orbital, you were placing 2 electrons. That means each of the electron is having half of orbital, isn't it? If you are sharing a book between 2 students, what will happen? Everyone is going to get a half. You share a chocolate between 2, you'll get half a share, right? That is why we have taken that number 1.5. Not not a whole number, but a fractional number. Again, it's an intelligent question, logical question, maybe asked sometime, right? That why we choose half. For others, we do not have any reasons to choose 0, 1, 2, or 3. But for this, we have a reason. Another thing, that whatever orbitals we have, whatever quantum number values for S, that N, L, M, they can be obtained by, there is an equation called as Schrodinger wave equation. Have you heard about it?
Yes, ma'am.
But the spin quantum number is not a solution of Schrodinger wave equation, right? Rest of the 3 quantum numbers can be obtained by the solution of by solving the particular Schrodinger wave equation, but spin quantum number are not found or not calculated by solving the Schrodinger wave equation, right?
Yes, ma'am.
Okay, now let's solve one more question. Number of electrons possible with N is equal to 3 and M is equal to 0 in zinc atom. Anybody knows the atomic number of zinc? Atomic number of zinc is 30. Quickly solve it.
Yes.
Are you ready with your answers?
Ma'am, is it 2?
I didn't get you. Please repeat.
2, ma'am.
2.
First
Okay.
option.
Okay. See, look at the solution. Please pay attention, students. See, we have asked you to find out how many electrons will have n is equal to 3 and m is equal to 0, right? If you look at these configuration, you simply has to focus, your focus has to be on 3s2, 3p and 3d. When you write the quantum number values for 3s2, what will be, you will be writing n is equal to 3, L is equal to 0, M is equal to 0, and S is plus half and minus half. That means how many? 3s2, both the electrons will have M key value as 2. If I look for 3p6, right? Now that 3p6, how will you go about it? N is equal to 3, L is equal to 1, isn't it? L is equal to 1 again. There will be plus half, minus half, 2 electrons, right? L will be 1, M will be 0, 1. I was just trying to do a shortcut. M is equal to 0, minus 1, plus 1. M is equal to 0 will have plus half and minus half. And similarly, 3d10, there will be 1 having M is equal to 0. Again, 2 electrons, making it as 6. Anyone who got 6 as the answer?
Yes, ma'am, understood it.
Good. So just the question appears to be so simple, but it may be a bit difficult. So 6 is the correct answer. Now, talking about another element or another question, the number of unpaired electrons in Ni nickel is nickel 2 plus, iron is. Atomic number of nickel, I can give you, it is as, it's 28. I believe you understand the terminology unpaired and paired electrons.
Ma'am, 4, ma'am.
4. Okay. How did you get that 4?
Ma'am, it's ion, ma'am, so it loses 2 electrons. And then
See, you have to draw the Hunswala boxes. We write it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. This is for nickel, right? Now for nickel 2 plus, the most important point is whether the electron will be lost from 4s or 3d.
3D, ma'am.
3d. Who says and why? Let us draw the picture of orbit again. I believe all of us agree that it is the valence shell electron which take parts in chemical bonding. What is the valence shell of this particular or for this particular atom? Any answer? Yeah,
4s2, ma'am.
4s2. Agreed. So from where, and more importantly, if you draw the picture of atom, where will you be able to see that electron? In the 4th orbit, which is the valence shell, right? So 4h2 will be giving out electron. Nickel 2 plus will have configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d8, right? That means what we have to draw? Everything 1s2, 2s2, 2p6, 3s2, 3p6, all are paired. 4s has got no electrons. And if I talk about 3d8, would you want to change your answer or you will still stick with 4? You will have 5 electrons of parallel spin like this, and then you will pair up 3 of them. So yeah. So number of unpaired electrons to me are 2. Do you agree or not?
Yes, ma'am.
Okay. So again, to end the class, I will say, please revise your concepts of whatever we have taught to you in structure of atom or periodic classification. The 2 chapters, including chemical bonding, are intermixed with each other, right? By asking this, we have asked you about the configuration of ions, which actually I have not taught, but you are taught in your schools, right? Now, have you heard about the term paramagnetic and diamagnetic?
No, ma'am.
Okay. In physics, you must have been taught or just understand one fact that whenever a charged body is moving, it is going to generate magnetic field also. Now, when 2 electrons are moving in the opposite direction, the magnetic fields developed by them are cancelled out. So diamagnetic means when we use that nickel, I might have asked the question that whether nickel 2 plus is paramagnetic or diamagnetic. So we say the correct answer will be it is paramagnetic. Diamagnetic, it will be the answer when all electrons are paired. That is, half of them are developing a clockwise magnetic field, other ones are generating anti-clockwise magnetic field, right? So therefore, they will cancel each other. In paramagnetic, in this case, till now it is fine. The spins are being cancelled, but here you have unpaired electron. That is why it is a paramagnetic compound or ion. Instead of nickel 2 plus, I can give you nickel sulfate or nickel chloride, anything. Then you have to find what is the charge on, if I, instead of nickel 2 plus, if I have given you NiCl2 or Ni2SO4, NiSO4. NiCl2 means nickel has di positive. That's another way of asking a question, right? So the concept of paramagnetic and diamagnetic also clear to all of you or not?
Yes, ma'am.
Okay, let's take the homework for the day. That you will be writing all the quantum number values for the following atomic orbitals. I'm giving you 2p2. Let's say 5d4, 6s1, 4p6, 3f5, and 7f14. All quantum number values for them. And this is, I'll just number them. This is 1, 2, 3, 4, 5, 6, and I will put one more. I'll just give you 4D. Is it clear to all of you? Have you noted the homework?
Yes, ma'am.
Okay, then is there any other query which has resolved, which is not resolved till now?
No, ma'am.
Okay, then let's end the class at this note, and we'll meet you in the next class.
Thank you, ma'am.
Welcome.